Hello everyone and welcome. In this video, we're going to explore the Network Time Protocol or NTP. We'll see how NTP ensures that all of our devices have accurate time, keeping our networks running smoothly and securely. Get ready to dive into the world of time synchronization across networks. So, what exactly is NTP? Network Time Protocol is essentially a networking protocol used for clock synchronization between computer systems. This synchronization occurs over packet-switched, variable latency data networks. It synchronizes clocks across distributed systems, achieving accuracy within milliseconds on local area networks, or LANs, and it operates using User Datagram Protocol, or UDP port 123. Why is time synchronization so important? Firstly, security. Accurate timestamps are crucial for authentication protocols, validating certificates, and identifying any security breaches. Secondly, data consistency. Distributed databases and systems depend on synchronized clocks to maintain the correct order of transactions and ensure data integrity. Finally, for effective troubleshooting. Having synchronized logs across different systems greatly simplifies tracing events and diagnosing network issues. Let's break down how NTP operates. The first step involves the client sending a timestamp request packet to the NTP server. Next, the server receives this request, adds its own timestamp to the packet, and then sends it back to the client. Once the client receives the response, it records the arrival time and calculates the network delay. Finally, the client adjusts its own clock based on the server's time and the calculated offset to ensure accurate synchronization. NTP uses a hierarchical system of time sources known as Stratum Levels. Stratum 0 is the most accurate level and refers to reference clocks like atomic clocks. Stratum 1 servers are directly connected to these reference clocks and are considered primary servers. Stratum 2 servers receive their time from Stratum 1 servers and are secondary servers. This continues with Stratum 3 servers getting their time from Stratum 2 servers and so on. Each level provides time to the next, creating a reliable and distributed timekeeping system. Now let's look at a basic NTP client configuration. Here is an example using a Linux or Unix-based system. The configuration file is located at /etc/ntp.conf. We specify NTP servers to synchronize with using the server command, often using a pool of servers like pool.ntp.org. The iburst option sends a burst of packets for faster initial synchronization. The drift file stores the clock frequency offset to improve accuracy over time, and access control rules can be set using the restrict command for security. Some common NTP commands include ntpqb to check synchronization status, sudo datepool.org to force time synchronization, and systemtal status NTP to check the NTP service status. To wrap things up, here are some best practices for NTP. Use multiple NTP servers to ensure redundancy and improve accuracy. Configure proper access controls to protect against NTP amplification attacks. Use geographically distributed servers to reduce network latency. For security-critical environments, consider implementing NTSec or authenticated NTP. And remember to regularly monitor NTP synchronization status and offset values. In summary, NTP is crucial for maintaining accurate time synchronization across networks, utilizing a hierarchical system and advanced algorithms. Proper time synchronization is essential for security, distributed systems, logging, and various other network applications. For further learning, check out the NTP Pool project, NTP documentation, the NTSec project, and RFC 5905 for the Network Time Protocol version 4. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.